Ice ages and Earth wobbles. Earth has wobbled many times in the past, from what geologists have found. For more than a century, scientists have known that Earth's ice ages are caused by the wobbling of the planet's orbit, which changes its orientation to the sun and affects the amount of sunlight reaching higher altitudes, particularly the polar regions. The Northern Hemisphere's last ice age ended about 20,000 years ago, and most evidence has indicated that the ice age in the Southern Hemisphere ended about 2,000 years later, suggesting that the South was responding to warming in the North. But new research published recently in Nature shows that Antarctic warming began at least 2 and perhaps 4 millennia earlier than previously thought. Most previous evidence for Antarctic climate change has come from ice cores drilled in East Antarctica, the highest and coldest part of the continent. However, the US-led research team studying a new ice core from West Antarctica found that warming there was well underway 20,000 years ago. Sometimes we think of Antarctica as a passive continent, waiting for other things to act on it, but here it is showing changes before it knows what the North is doing, said T.J. Fudge, a University of Washington doctoral student in Earth and Space Sciences and lead corresponding author of the Nature paper. Co-authors are 41 other members of the West Antarctic Ice Sheet Divide Project, which is primarily funded by the National Science Foundation. The findings come from a detailed examination of the ice core taken from the West Antarctic Ice Sheet Divide, an area where there is little horizontal flow of the ice, so the data are known to be from a location that remained constant over long periods. The ice core is more than 2 miles deep and covers 68,000 years, though so far data have been analyzed only for layers going back 30,000 years. Near the surface, 1 meter or 3 feet of ice covers 1 year, but at greater depths the annual layers are compressed into centimeters. Fudge identified the annual layers by running 2 electrodes along the ice core to measure higher electricity conductivity associated with each summer season. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Evidence of greater warming turned up in layers associated with 18,000 to 22,000 years ago, the beginning of the last deglaciation. This deglaciation is the last big climate change that we're able to go back and investigate, he said. It teaches us about how our climate system works. West Antarctica is separated from East Antarctica by a major mountain range. East Antarctica has a substantially higher elevation and tends to be much colder, though there is recent evidence that it too is warming. Rapid warming in West Antarctica in recent decades has been documented in previous research by Eric Steig, a University of Washington professor of Earth and Space Science who served on Fudge's doctoral committee and whose laboratory produced the oxygen isotope data used in the Nature paper. The new data confirms that West Antarctica's climate is more strongly influenced by regional conditions in the Southern Ocean than East Antarctica. Let's remember that West Antarctica has a lot more active volcanoes underneath it. Okay, there's 147 volcanoes already discovered in Antarctica. The most volcanoes in the world are there. This is surprising, but that's what's happening. Now, Fudge said it's not surprising that West Antarctica is showing something different from East Antarctica on long time scales, but we did not have evidence for that before. He noted that the warming in West Antarctica 20,000 years ago is not explained by a change in the sun's intensity. Instead, how the sun's energy was distributed over the region was a much bigger factor. It not only warmed the ice sheet, but also warmed the Southern Ocean that surrounds Antarctica, particularly during summer months when more sea ice melting could take place. Changes in the orbit today are not an important factor in the rapid warming that has been observed recently, he said. Earth's orbit changes on the scale of thousands of years, but carbon dioxide today is changing on the scale of decades, so climate change is perhaps happening much faster today, Fudge said. This was from the University of Washington press release on Bended Reality. Please leave your comments and thank you for your support.